Let us prove the statement if f is Riemann integrable on closed interval a comma b. Assuming this, we have to prove that mod modulus of integral over a to b f of x dx is lesser than or equal to integral over a to b mod f of x dx. Mod f of x dx, right? So let us take this assumption. F is Riemann integrable. So as we know that if f is Riemann integrable, mod f is also Riemann integrable over closed interval a comma b. And as mod f is also Riemann integrable on closed interval a comma b, minus mod f is also Riemann integrable over closed interval a comma b. See, from f belong to Riemann integrable over a comma b, we have obtained mod f and minus mod f are Riemann integrable over closed interval a comma b. It is given, and these two are the conditions which we have written from this given part. Right now, as we know that or we have minus of mod f of x is lesser than or equal to f of x less than or equal to mod f of x. Here negative modulus of f of x is present, and here positive mod f of x is present for every x belongs to closed interval a comma b, right? That means here if we check the values once, minus mod f of a, right, minus mod f of a will be less than or equal to f of a, right, f of a less than or equal to plus mod f of a, right, plus mod f of a, right? So see here at x is equal to a, this inequality will be true. So if we substitute b also, then also we can write it as minus mod f of b will be less than or equal to f of b, right, less than or equal to plus mod f of b, right? And the same condition will be true for every values which are lying in between a and b, right, which are lying in between a and b, right? So if we take a real number line, and on real number line if we take closed a comma b, right, and if we take a point c in between a and b, right, if we take a point c in between a and b, then this condition will be true for this point c also. That means minus mod f of c will be less than or equal to f of c will be less than or equal to plus mod f of c, right? A value c which is lying between closed interval a comma b, right? So from given part we have obtained minus mod f of x is lesser than or equal to f of x less than or equal to plus mod f of x for every x belongs to closed interval a comma b, right? So from here minus mod f of x is less than or equal to f of x is less than or equal to plus mod f of x for every x belongs to closed interval a comma b, right? From this mod f of x we have changed this as minus mod of f of x less than or equal to the f of x is remaining as the same, and the plus mod f of x is changed to mod f of x, modulus of f of x, right? Next, applying this integral over a to b on both sides. Applying this integral over a to b on not both sides for whole of the terms which are lying in the above inequality. There are three terms in the above inequality. So we apply integral over a to b for the first term, for the second term, and for the third term also, right? Therefore integral over a to b minus modulus of f of x dx lesser than or equal to integral over a to b f of x dx lesser than or equal to integral over a to b mod f of x dx, right? So if we apply integral over a to b on the whole for each and every term of inequality, this inequality less than or equal to does not alter, right? So next, the next step, see the next step, minus integral over a to b mod f of x dx is less than or equal to integral over a to b f of x dx less than or equal to integral over a to b mod f of x dx. Is there any change? Means we have put this minus sign before this integral in this step, in this inequality, right? Now, if we proceed further, see what will happen. What is the next step, right? See here, minus is put outside of this integral over a to b mod f of x dx less than or equal to integral over a to b f of x dx less than or equal to integral over a to b mod f of x dx, mod f of x dx, right? So see here, if minus a less than or equal to x less than or equal to a is written, then we can take this as mod x is lesser than or equal to a, mod x is less than or equal to a. So if you observe carefully, it is, see here, instead of minus, minus is present, right? So, and instead of a, let us see what is present. Instead of a, right, here integral over a to b mod f of x dx is present, right? And next, so see here in between, instead of x in between minus a and plus a, here integral over a to b f of x dx is present, right? And here instead of a as the last term in this inequality, here integral over a to b mod f of x dx is present. Mod f of x dx is present. Therefore, applying this minus a less than or equal to x less than or equal to a, right, as mod x less than or equal to a, therefore we have written as mod integral over a to b f of x dx less than or equal to integral over a to b f of x dx, integral over a to b f of x dx. This is what we have to prove. Therefore this theorem is being proved, or this inequality is